welcome back to the high entropy zone again, and once again I apologise for my my lack of videos. Some of that's just down to just not feeling up to coming out to the workshop and doing anything. Some of it's jobs that I just needed to get on with, and any of you that make videos know that making a video of doing a process always makes the process that much longer. I've been to the big classic bike show at Stafford Showground, manning the club stand as usual. It was a little bit harder work this year because my friend who usually helps me out with loading has moved back up north, so I was loading bikes and unloading bikes on return. Solo, but it was a good show. Didn't shoot any footage up there. I was pretty busy talking to people. In fact, on the first day I barely made it away from the stand to go and see anything. But I did do a bit of rooting around on one or two of the trader stands and found a few bits and pieces which I'll show you that I was quite pleased with. And had several channel subscribers come up and say hello, which is great. Get good feedback on the Marini videos in person, if rarely in the comments. But one of my subscribers, Ian, came up and asked about the stand for my cylinder boring bar, and I think in the last report I'd shown the slab of ground steel, and I hadn't made a start on it, and he said, well, I've got a spare SPS stand that you can have if you come up and collect it. So I went up to Ian's workshop, and he works on bikes as well, but he works on them for dealers rather than the public, or as simply as a hobby. And yeah, nice collection of machines, and great chat and great to see him, and a very generous gift, which certainly means that the boring bar can be put to use a little quicker. And we'll have a little look at that, and some of the things I need to do to make it operational, minor stuff. The workshop has filled up a bit again. One of the projects I've been working on is a gas flow bench for cylinder head work, and this is actually a project I started years ago and got stalled for a number of reasons, and due to my friend Roy, who normally helps me for the shows, moving away, we've been building it at his place, and it had to come, so it's now taking up an inconveniently large amount of floor space. But I have got some work done on it, and I'll show you the state of that and tell you a little bit about how it works. And that's the other thing I've been doing, is one of my least favourite things in the entire universe, which is writing software. There are offerings out there to do the data logging and processing of the data from a cylinder flow bench. Some of them are good and expensive, some of them are just expensive. The one produced by the guy who did, or sold by the guy who did the plans for the bench I built, in conjunction with a couple of people on the support forum, is good, but it has, and it's not terribly expensive, but it has some limitations for where I want to end up. And I'm nowhere near to the point where I want to show what I've achieved in the software in some ways it's been easier than I thought, in other ways more difficult. My previous programming experience was embedded C PIC processors and some VB6. The VB.NET with the much heavier object-oriented style of things has been a bit of an unpleasant learning curve for me, but actually some of the newer features have made things, some of the things I wanted to do, really easy. So I'm not unhappy at the progress I've made, but you know, on the evenings when I have felt up to doing something, it's been up to the loft where the video editing PC, and that's my only Microsoft PC, is up there to work on software. So I'm going to go handheld the other camera because my bench is too messy to get the camera stand in the right place, and we'll have a look at a few things. Okay, first of all, we have a set of involute gear cutters, and these are metric, they're mod 2, and I found these on a stand at the Stafford Classic Bike Show. It's a complete set apart from the 55 to 134 tooth cutter, but you know, these are a quality brand. They're all worn, not seriously worn. Some of them are, you know, they need a sharpen before being used, but these haven't been sharpened before. You can see that the as you sharpen the face there, these get shorter and the notch gets wider, and these appear to be the factory grind, and some of them I could probably actually restore just by hand with the diamond file, but I rummaged around in the boxes and found this set of 7. They were in 2 or 3 different boxes, and I spent quite a bit of time sorting through, and you know, there were other cutters in there, but there was maybe 1 or 2 out of a set, and mostly they were DP cutters, the Imperial standard. And then she came up with this set and said, you know, what do you want? And £20. Well, absolute no-brainer. Wallet came out quick as a flash and was handed over, and yeah, there was a couple of other bits and pieces maybe I was thinking about, but I didn't have time to go back. But very happy with picking up this set, and I'll keep an eye out for the missing one, and I'll quite happily go for a Chinese one. The ones I've seen in person are pretty good, and John Mills Double Boost bought a set to cut some gears for his Harrison lathe, and he hadn't twigged that the gears on the Harrison are in fact a hardened steel, and obviously the teeth were hard, and he used carbide to cut that, but it's still quite a tough steel, even towards the centre, but the Chinese cutters held up perfectly well to cut the ones he wanted. I'll keep my eye out. I mean, even better if I could actually find a matching brand, but in any case, good haul, and an even better haul came via eBay. And we all know good things tend to come in wooden boxes. Oh, that one's the new one, so that one hasn't even been out of its plastic wrapping. But let's go with this one. So it's a bit awkward doing this one-handed. But of course what we have here is a groove micrometer. See if we can focus in on the scale. So it's a 50 to 75 millimeter. You've got the two discs and the dual scale, which is inside and outside of the discs, and I got 3 of these. I got the 25 to 50, the 50 to 75, and the 75 to 100, and they were buy it nows on eBay, and I think they were $89 for the new one and $79 for the used but almost like new ones, and all the way from the Russian Federation, and yeah, very quickly dispatched. Great find. The guy's got some more tooling I might have a look at as well. So didn't particularly need them. Have had situations in the past when one would be handy, so when I saw them, had to have those come home. And we'll put those safely out the way. And a little thing, I picked up a puncture on my big Yamaha, which I still haven't resolved. I picked up a nail through the rear tyre, and a lot of places won't touch a Z or W rated tyre, and it's the high speed, it's the W rated. And there's not that many places locally which do motorcycle tyres anyway. And also I have an insurance issue at the moment. Got a letter telling me my bike, one of my bikes isn't insured, and checking on the database none of them appear to be. So whether the issue's with my insurance company or whether it's the official database that's screwed up, which I'm hearing is entirely likely, but means that you're highly likely to be stopped by the police, and if you haven't got proof of insurance, your vehicle will then be impounded and you'll have to pay to get it back, even if it's discovered to be an error on the part of the database, which is not fun. But anyway, when looking for the puncture, I wanted to pump it up. I have a little compressor that I can pick up and carry, and I couldn't find the adapter to go between the different tail fittings. This is the PCL style fitting, which is the common older one, and this is the Euro style or XF style that comes with a lot of the air tools you see these days. And eventually I did find the adapter so I could use my tyre inflator. But I was thinking, oh, wouldn't it be convenient to convert everything over onto the same fitting? So there's also a second advantage. The bore in the end of the PCL fitting is smaller than the Euro fitting, and the XF is extra flow supposedly, and they both have got the same 1/4 inch BSP, but you've got the bore's over. That's about a 5mm bore, and this is about a 6.2. So it's a significant increase in size. So I shall be converting everything over to the Euro style. You can also see that they're a little bit more compact. So down here we have the boring table that Ian so kindly gave me, and you can see I've got a couple of taps stuck in it. There's two threaded holes which take studs, which then holds the cylinder yoke. So you would obviously fit this, clamp the cylinder down, and then I need to make some rings to fit here to suit the different cylinders. But I was rummaging through my bolt box to see if I could find bolts that fitted in and identified the threads. You know, measuring inside threads with thread gauge is not the easiest thing in the world. Eventually I went to the thread gauge and was looking at the values and thinking, that's weird. I don't think this is this old, but clearly the design's quite old, because these are Whitworth threads, British Standard Whitworth, or the coarse thread, and the other two are British Standard Fine. So fortunately, inherited from my grandfather, I do actually have taps which I could come and confirm the threads with. And then I did a little bit of searching online and found myself some foot-long lengths of British Standard Fine studding, and so I now need to make some knurled nuts so that you can spin this up nice and quick. And you're seeing the stand in its inverted setting, because this is a flip over stand to make mounting the cylinders up easy. So give me a second and I'll get the other camera set up on the stand and we'll flip this over. So okay, the basic idea is you would load your cylinder up, drop the yoke on, clamp the cylinder in place, and then flip the stand over and lock it, and then you could take your boring bar and use the centering fingers to center it up, and then there's there should be another bolt that you use your clamping mechanism to clamp the thing down before boring the cylinder. Now, what I probably want to do is I actually want to raise this thing up to bench height. So I'll put either make this stand taller or just make a sub stand for it. The knees are not working brilliantly these days, and I'd rather not be crouching down to put cylinders on the table. We've got the cylinder head gas flow bench, and this is all in 18mm MDF with battens reinforcing it and biscuit joints. So there'll be a plate on top here to mount your dummy cylinder, then the cylinder head on top, and there's a chamber under here, and you have a boat deck plate to give access in there, so that forms a chamber. Obviously the back's missing at the moment. And onto this second hole here, you affix a metering orifice, so you know what the flow is at a given pressure drop across it. And then you have another chamber down the bottom, and you set a known vacuum in this top chamber, and a standard testing pressure is 28 inches of water. You then measure the pressure drop from this side to this side of the measurement orifice. This is the flow control valve. Where these buttons are, that's where the panel sits that has the vacuum cleaner motors mounted on it. And the chamber below this plate is divided in this direction, and you can see that there's a hole open here and a hole open here. And if I remove and flip this plate, it's changed the holes, so the back half of this chamber beyond these battens is the low pressure side. So with the plate in this way, air would be sucked in through the back of the cabinet up into this chamber. This front chamber, which has a plate that seals it, would then be pressurized. The air goes down this hole through into the bottom chamber, through the measurement orifice, and then up and through the cylinder head. And by performing the necessary calculations, you can calculate the airflow in cubic feet per minute or litres per minute, or whatever units you want to. Cubic feet per minute is kind of standard even in these days of metrification. But we'll swing around and have a look at the back. Now the pressures involved are not high. I mean, you're talking maybe 1.5 pounds per square inch, but if you think about the number of square inches of these panels, then the actual forces on them can become quite significant, so it does have to be built quite strongly. I've done a couple of things different compared to the plans. Obviously I had to convert some of the figures to accommodate the metric thickness material, but rather than doing square corners, I've gone for oak quadrant, so that the corners are much more resistant to general knocks, and they're not sharp. So now we've got the motor plate over here, and the design is able to accommodate up to 8 motors, which would give you the ability to test cylinder heads up to about 600 cubic feet per minute, which is you know, into your big block V8 territory. Nothing I'm ever likely to do, but the facility is there. I suspect I'll only fit 4 motors. I have 6. They're the motors from the Dyson DC01. So I'll just go and grab one of those, and we'll look at another little thing that I've got to work on. Okay, so here's one of the Dyson DC01 motors, and I picked these up for £5 each. There was a guy on eBay who used to dismantle them for spares. Now, if you're running all the motors on a speed controller, so you can get your test depression, that's fine. You just run all the motors at once and vary the speed of all the motors, but that's a big motor controller. So the other way of doing it is to run the motors individually and just speed control one or perhaps two. But then you need to stop the air flowing back through the motors you're not using. And one of the ways of doing that is to use a scupper valve. So it's just a one-way rubber flat valve, and this is what the they sell. The guy who designed the bench has a website. It's flowbenchtech.com, I think, but it's the PTS flow bench design. Good forum, good support, lots of successful examples out there. But I worked out from the pictures what valve that this was, and I could get it in the UK because it's mostly based in the US. And I got a bunch of these in, but then I was comparing the size of the valve to the aperture in the motor, and the actual airflow through the centre of the valve is smaller than the aperture. So I was just going to use, I've got some of this really heavy wall PVC pipe which is used in chiller systems, and you know, it's going to be a reasonable fit to the valves and would mount on the far side of the motor plate. But I'd like to be able to run the minimum number of motors at any one time, both from the power consumption and the noise point of view. So if these restrict the airflow, I might have to turn an extra motor on. So I'm going to see if I can come up with a larger bore, higher flow one-way valve. So that's something I'm going to start thinking up in probably in Fusion 360, and I've got a few thoughts, and I've done some rough calculations, and I can get more flow, or more flow area than you get in this the orifice on the motor. So that hopefully will be a little upcoming project. And I think that's just about it that's going on at the moment. This bike's still sitting on the bench, but I'm hopefully having someone come to look at it with a view to buy next week. So with a bit of luck, this one will be out of here, and I can have a little bit more room to work. And thank you all for stopping by. I do appreciate the comments and the feedback, especially in person. And we'll try and keep producing stuff through the winter, and I hope to have you all back here soon. Thanks a lot.